In the high-stakes world of oil and gas, well testing used to be, well, a bit of a guessing game, but not anymore. It's transformed from an art form into a hard science. So today, we're going to dive into that evolution, from guesswork to guarantee.
And I mean, the difference is just night and day. Think about it. The old way, it was all about rules of thumb, gut feelings, which, let's be honest, came with a huge amount of risk. Now, compare that to the modern way. We're talking intelligent design, totally data-driven, and built from the ground up for safety and efficiency. This change, yeah, it wasn't just a nice to have. It was absolutely essential.
So that begs the question, right? Why the big change? Why couldn't we just stick with the old ways? What was it that really forced the industry to demand something smarter, something more reliable?
Well, it really boils down to four huge pressures. First off, safety rules got way stricter. You just couldn't take the same risks anymore. Then you've got environmental concerns, which went from being an afterthought to a top priority. Of course, there's always the money, right? The demand for cost efficiency is just relentless. Every single hour on a rig costs a fortune. And finally, the reservoirs themselves got more complicated, and managing them needed a level of detail the old methods just couldn't dream of providing.
And that really sums up the new reality. A well test today isn't just some simple procedure you do on site. Oh no, it's a full-blown project, planned out with incredible detail and scientific rigor long before anyone even thinks about heading out to the field.
Okay, so this brings us right to the heart of the modern method, what we're calling the intelligent blueprint. The whole idea is to design the perfect test right there on a computer before you ever step foot in the field. So let's break down how that actually works.
It's actually a pretty straightforward three-step process. First, you figure out your zonation and objectives. What are we actually looking for? Step 2, you simulate the entire test sequence from start to finish. And then, third, you run a deep dive analysis on that simulation. It's basically your roadmap to getting it right the first time.
Let's talk about that first step, zonation. What's so cool about this is that it's all about focus. Engineers take all the existing geological data and basically slice the reservoir into these distinct vertical zones. Why? Because it lets them ask super specific questions and figure out exactly what kind of test they need to run to get the answers they're looking for.
But that leads to a pretty mind-bending question, doesn't it? I mean, if you haven't even run the test yet, how on earth can you know what's going to happen? How can you predict the results and get ready for them before anyone is even on site?
The answer is powerful sequence simulation. And the best way to think about this is like a digital dress rehearsal for the real thing. I love that analogy. Using incredibly powerful software, analysts can model the entire test. I'm talking everything from opening a valve to flowing the fluids, and they get to see exactly how the reservoir is going to respond. It's literally like watching a movie of the test before a single camera starts rolling. Okay, so you've run the simulation. Now comes the really critical part, analyzing it. You get two main things out of this. On one side, you have diagnostic plots. These tell you when you can expect to see those key reservoir features pop up in the data. On the other side, you have sensitivity plots. These are amazing. They let you see how the test duration might change if, say, your initial guesses about the reservoir were a little bit off. What this does is it lets you build a plan that's not just good, but also robust and flexible. All right, so the digital blueprint is done, it's been tweaked, it's been optimized. Now the focus totally shifts from the virtual world to the physical one. It's time to actually pick the tools and the hardware that are going to bring this perfect plan to life. And this isn't just about grabbing stuff off a shelf. Every choice is guided by that initial design. You need tools that can control the environment deep downhole. You need equipment that maximizes efficiency, because every second of rig time saved is a huge win. You obviously need super precise gauges to make sure the data you're getting is reliable. And of course, number one priority is guaranteeing safety and making sure all the fluids are handled properly. You know, this statement really says it all. The goal is to ensure flexibility and safety while acquiring the most accurate data possible. It's a perfect summary. It's this constant balancing act, right? The gear has to be flexible for any surprises. It has to be completely safe for the crew, and it has to be so precise that the data you get is absolutely rock solid. So you go through all this, the intelligent planning, the simulations, the careful equipment selection. What's the payoff? Why do all this work? Well, this is where it all comes together. This is how smarter testing gets you way better results. Because what you get at the end of the day, it's not just a spreadsheet filled with data points and pressures. Not at all.
The real result is a deep, fundamental understanding of the reservoir itself. You learn how it behaves, what it's truly capable of, and how to manage it for the long haul.
And really, when you boil it all down, this whole process is about one thing: confidence. We're talking 100% confidence. It's about giving companies the certainty they need to make those massive, multi-million-dollar decisions about an asset's future. It completely transforms high-risk guesswork into a guaranteed data-backed strategy.
And that kind of leaves us with one final thought to chew on. We've just walked through this incredible leap from simple rules of thumb to these complex digital simulations. But as our technology, our computing power just continues to skyrocket, you have to wonder, right? Just how much more precise can these digital dress rehearsals actually get? What new secrets are they going to unlock for us down the road?